All right, 3.7, modeling using variation. So this section, last section of chapter 3, is going to use variation to set up these problems for us. And yes, there will be other ways that you could solve these applications on these word problems, but for this section, they're using variation. That's why it says modeling using variation. So I'm not talking about other ways of doing it. There are other ways of doing these problems, but this is specifically discussing the way to solve these problems using variation. So we're going to have keywords or key expressions that's going to help us to set up our problems. The first one we're looking at is direct variation. So if we see the phrase y varies directly as x, and y and x just represent our unknown variables, they can be anything, but you'll see in a second. Y varies directly as x, or y is directly proportional to x, would cause us to set it up or set up our problem this way. Y equal to k times x, and k is going to be our constant of variation. So y just represents what comes before the phrase, x represents what comes after the phrase, but that k will always be there. So when we go to establish our variables, what we do not want to use, because we don't have to use y and x, but what we do not want to use is k, because k will always be a part of these variation problems. So in other words, let's say we have kinetic energy. We wouldn't want to use k for kinetic energy. We could use E, for the energy, to represent energy. So that K will always be a part of our variation setup. All right, scroll up. Okay, all right, so that's our first problem. Matter of fact, we'll put a line between. The distance that a body falls from rest varies directly as the square of the time of the fall. If the skydivers fall 64 feet in 2 seconds, how far would they fall in 4.5 seconds? All right, give you a chance to write that down. All right, so we have our key phrase that we want to look at first. We want to find the key phrase um, for us, and it's going to be varies directly as. That's our key phrase. So what comes before our key phrase is going to be our y, and then what comes after that key phrase will be x. Now I'm going to have the steps set up. If we follow these steps, then we should be good no matter what problem that we have. So the first one is to identify the variation setup, and that's what I just mentioned. It varies directly, so we'll be using the setup of y equal to k times x. Second, we want to establish our variables, and we do that by first looking at our key phrase, varies directly. What comes in front of that is the distance that a body falls from rest. So that's going to be d for distance. After that, the square of the time of the fall. So we use t for time. It's up to you what variables you want to use. Probably be best if you use something that is close to what you're dealing with. Like I use d for distance, t for times, t for time. But if I want to use r for distance and z for time, I mean that's fine as long as you know what you're doing. So that's what I decided to use. Any questions on step one, step two? All right, so we write the equation. So the distance the ball falls from rest, that's d equals, varies directly as the square of the time. So we know we're going to have to use k times t, but it says square of the time. So it's k times t squared. So the distance varies. So that's why we have d equals. That comes before the varies directly phrase. We're going to have k involved. K is always a part of all of these variation problems. constant of variation. And then it says this time squared, so that's why we have t squared. All right. Step 4, write down all the given info. So what happens is in all of these problems, they'll give you a complete set of information. Then they'll give you the information with one of the pieces missing. And that will be the case with all of these problems that you get. So you write down your given information. You'll have a complete set of information first, and then you'll have the information with one piece missing. All right. So step 5, we'll use the equation and the first set of information to find K, our constant of variation. And these problems aren't really that long, but when we take time pausing and explaining, it may seem long, but once you get in the flow, just do the steps, walk through them. The problems aren't that long. So our equation is D equal to K times T squared. So you plug in D1 and D2. So the 64 equal to K times 2 squared. That'll be 64 equal to 4K divided by 4. K is equal to 16. All right, so everybody okay with that? All right. So we can substitute K into the equation now. So it's going to be, because remember, it's the constant of variation. That K is going to be the same throughout the whole problem. So that's why it's called a constant of variation. So that's going to be D equal to 16T squared. And now we can use the second set of information and the new equation, we're talking about this week, 16 in it, to find the missing piece. So our second T was 4.5. Plug it into the equation. 16 times 4.5 squared will give you 324 feet. All right, questions. All right, any problems before we go to the next one? All right, so let's look at inverse variation. Same setup, not same setup, same process, different setup. So here we're looking at inverse variation. Y varies inversely as X, or Y is inversely proportional to X, will prompt us to set up a problem this way. Y is equal to K over X. All right. All right, so when you use a spray can and press the valve at the top, you decrease the pressure of the gas in the can. In general, if the temperature is constant, the pressure of a gas in a container varies inversely as the volume of the container. And it says the pressure of the gas sample. Okay, I'll scroll up a little bit in a second. Let you guys write that. All right. So the pressure of a gas sample in a container whose volume is 8 cubic inches is 12 pounds per square inch. If the sample expands to a volume of 22 cubic inches, what is the new pressure of the gas? All right. So let's go through the steps. So we know that the process or the setup that we're going to use is inverse or inversely. So decided to use P for pressure and V for volume. So if you go back to the setup, it says Y varies inversely as. So what comes before the inverse, the varies, is going to be our first variable. So that's right here, the pressure of the gas in a container varies. So pressure P, then after will be our next variable, varies inversely as the volume of the container. So that's why I got V for volume. All right, you see our third step, we go ahead and plug in the variables that we're using in place of Y and X. Notice K is still a part of the equation. Write down your given information. So to give us the first set of information was 12 for the pressure, 8 for the volume. Then they asked us to find the volume, not to find the volume, find the pressure. But the volume increased to 22 cubic inches. Yep, 22 cubic inches. All right. Step 5, plug in the first set of information into the equation so we can solve for K. So 12 for P, 8 for V. Multiply 8 to both sides. K will be equal to 96. All right. Plug K back into the equation. P is equal to 96 over V. And then plug in that V, that second V, so we can find the second P that corresponds to it. So plug in 22 for V. 96 divided by 22 will be 4.36. Questions, questions, questions. All right, very good. Before we scroll up, all right. So combined variation is when more than one variation is used. And joint variation says y varies jointly as x and z. So notice it just means multiply x and z to the k. All right, so let's look at the next one. The centrifugal force of a body moving in a circle varies jointly with the radius of a circular path and the body's mass, and inversely with the square of the time it takes to move about one full circle. Give you a chance to write that before I go up. All right, a 6-gram body right here, a 6-gram body moving in a circle with radius 100 centimeters at a rate of 1 revolution in 2 seconds has the centrifugal force of 6,000 dynes. Find the centrifugal force of an 18-gram body moving in a circle with radius of 100 centimeters at the rate of 1 revolution in 3 seconds. All right, I know it sounds like a lot, but if you take your time, go through the steps, it won't be that bad. All right, can I scroll up? Everybody good? All right, so this one involves jointly and inversely as our key phrases. All right, so jointly we just mentioned k times x times z. Inversely is k over x. All right, and we see that when we go back up here. See varies jointly, varies inversely. So, but before we get into that, let's establish our variables. Before we get into actually bringing those together, let's establish our variables. First variable we see is our centrifugal force, so I'll use C for that. And then you see our radius, our mass, and inversely with the square of the time. So we have right here C for centrifugal force, R for radius, M for mass, T for time. All right. Okay, before we go to the next thing. All right, so let's look at how we're going to set this up. Once again, the first letter that we come across, or the first variable that we come across, is our centrifugal force. And that comes before varies, so that's going to be C equals. Then it says it varies jointly with the radius and the circular path, radius of the circular path, and the body's mass. So if you look at the setup I have here, this is the jointly part. It varies jointly with the radius and the mass. So that's K times R times M. And then it says, but inversely with the square of the time. So that's why I have T squared down bottom. All right, questions on the setup? Step 3 before we go to step 4. All right, so now we're going to write down our given information. So the first set of information is right here. Once again, remember I told you before, they're going to give you all of one set of information, then have a missing piece from the second set of information. So we had 6,000 dimes, 100 was the radius, mass was 6, and then the time was 2 seconds. And then over here, we want to know what's the centrifugal force. If you have a radius of 100, mass of 18, and then a time of 3 seconds. All right. Problems before we go to the next step. All right, so now we're going to take this first set of information, plug it into our formula to find K. That's what we did here. 6,000 is equal to K times 100 times 6 over 2 squared. All right, that simplifies to 150. So we have 6,000 equal to 150K divided by 150, and K is equal to 40. All right, so now we can substitute 40 in for K. So our new formula, new equation is C is equal to 40 times R times M over T squared. All right, so now we can plug in all of the pieces that we know to find the piece that we do not. So it's 40 times 100 times 18 divided by 3 squared. That would be 8,000. 8,000 dimes. All right. Questions. All right. Let's see. I think that's it. Okay. All right. Any questions before I come off this page? All right. So we're getting ready for our third test, which would be 3.1 through 3.7. And then the content that I know that we have to get through is going to be 4.1 through 4.4. That's chapter 4, our fourth test. All right. So, so today is the 29th. All right. So, last time we tried to take a test, didn't work for us. My math lab went down, which is all good. So we're going to go ahead and try to do it this time. So we did 3.7 today. Review next class. And so, yeah, we can look to take the test next week. And so the same option will be afforded to you, like I mentioned before. The first test will be proctored. And then there will be a makeup that will show up after this is taken. So this class starts at 11. And then so I guess sometimes after 12, it'll pop up. Got to set a timer. I haven't set a timer yet. So the difference between the two, see here, the highest score you can make is 100%. Of course, that's just regular. And then here, highest score you can make is an 85. Once again, just re-emphasizing the fact is I'm not minusing 15 points from whatever score you get. If you score 75, then your score is 75. I'm not going to minus 15 from it. But let's say if you score 90, the highest grade, the cap that I will take for this test would be 85. So if you score higher than 85, the score will be 85. And that's because, you get 2 attempts as well. And so you really could have had 3 shots at that test to get get a grade that you want. So, like I said, we haven't proctored any tests yet. So we need to get, at least one of them in there before the final. So this will be our proctored test. Questions on that?
So we're having this test on the 5th?
Yes.
Okay, thank you.
Not a problem. Anything else? Anybody else? So, like I said, next Monday is when we'll do this. Next class will be all review. Make sure you take a look at the test review. You know, the test review will help set you up for the test. Um, it's not mandatory to do, but you at least want to take a look at it and see, you know, what questions you may have going into the test. And then that'll let you know what you need to ask me coming on Wednesday. All right.
I'm sorry, I have a question. What do you say about 4.1 and 4.4?
I would just let you know that that's what we most definitely need to cover, closing out
Okay.
the class. You know, there's certain things that, you know, in the class that you say, like when you get closer to the end of the semester, it's like some stuff, yeah, we get to it, we don't, fine, we're not. But, you know, these four sections we do have to cover before we leave this class.
Okay, thank you.
Yep. So just let you guys know that at the least we have four sections left. So after those four sections, we may go further, we may not. Depends on, you know, the status of the class, how we're going, where we are, how much time we have left. Is, you know, does it even matter to go into something new at that point? So that's what I was saying. We know we're gonna do 4.1 through 4.4, but we may not do anything else after that. All right. Everybody good? Any questions before we close out? Is everybody okay?
Mm, thank you.
All right, not a problem, not a problem. All right. So you guys, I will see you on the next class with the review in mind, and we will go from there. Yeah, guys, have a great one.